First of all, the name of the chapter is the chemical equilibrium. Uh, Let me just start the annotations. Yeah. Uh, yes. So you can see that this is the name of the chapter, that is chemical equilibrium. So before we should move on to the definition of chemical equilibrium, I think we should start with what is a chemical reaction. A chemical reaction hota kya hai? So a chemical reaction is basically a conversion of reactants into products, as I have shown here. That these are the reactants, and these reactants are being converted into the products, and there will be some certain reaction conditions. There will be reaction conditions as well. No? Those reaction conditions can be of temperature, pressure, or any other catalyst or this type. But the question is reaction conditions तो हम लोग डिस्कस कर लेंगे बट व्हाट आर रिएक्टेंट्स एंड व्हाट आर प्रोडक्ट्स बेसिकली सो हमें ये बेसिक सी चीजें स्टार्ट करने से पहले ये पता होनी चाहिए तो केमिकल इक्विलिब्रियम तो आप देख ही लेंगे सो व्हाट आर द रिएक्टेंट्स बेसिकली आर द स्टार्टिंग मटेरियल्स फ्रॉम व्हिच we are starting a chemical reaction. So I have written it here in the form of bullet that starting materials from which a chemical reaction starts. These basic three definitions are not given in your book, but you should know about this. Starting material from which a chemical reaction start is known as basically a reactant. It is always written on the left side of the reaction. Like I have written, hang on for a sec, let me erase this. Yeah. Now, as you can see that this is a chemical reaction that I have shown you guys. And on the left hand side, I have written the reactants. So this shows that the reactions are always written on the left hand side, and the products will always be written on the right hand side. So let's move on to the towards the products. Product is basically the end results or ending material of a chemical reaction. Whenever there is a chemical reactions, there will be some certain reactants that will be converted into products. So whenever these reactants are converted into products, we'll say that these are the ending materials. Let's suppose we wanted to prepare water. So what we'll do is we'll take hydrogen and oxygen. So hydrogen and oxygen will be our reactants, and the water which is producing after the which is producing at the end of the reaction, so that will be our product. So ending material or results of a chemical reaction is known as product, and it is always written on the right side of the reaction as I have shown you here. So now let's move on towards the next part, that is let me just wait I have to stop the annotations. Yeah. So moving on to the fourth definition, that is reversible reaction. So there are two types of reactions that are discussed in your book. First one is reversible reaction, then the irreversible reactions, and there will be two certain examples of these two reactions. We'll discuss it from the book, and after that we'll be moving on towards the chemical equilibrium, the basic definition of the chemical equilibrium. What is chemical equilibrium? The name of the chapter is chemical equilibrium, so we should know about the chemical equilibrium. But before we should move on towards the chemical equilibrium, we must know about these basic terminologies. So let's just say that what is a reversible reaction? So again, let me start with the annotations. Yeah. So reversible reaction are those reactions in which products formed can recombine to produce reactants. Like uh, if you guys remember that I have written a reaction in which the reactants R is being converted into products. So there will be some certain reactions in which these products formed can recombine to produce reactants as well. So these types of reactants are known as reversible reactions. Okay, these reactions never goes to completion. Why? Because the reactants are being converted into products, and the products formed will recombine to form reactions. So this becomes a cycle, and the cycle will continue its process. It does not stop. So that is why these reactions does not go to completion. They are represented by double-headed arrow. Why? Because the reactants are converted into products. This is the first arrow, and products are being converted into the reactants. So this is the second arrow. So that is why they are represented by putting a double-headed arrow. And the last point is that they can be achieved in a closed system. What is a closed system or what is the open system? What is an open system? We'll discuss these two types in examples. Now, moving on towards the irreversible reaction. The irreversible reaction is the very exact opposite to the reversible reactions. Reversible reactions are those in which the products formed can recombine to make reactants. But in irreversible reactions, the products formed cannot recombine to form reactants. It does not recombine to form reactants. So that is why these reactions goes to completion. Why? Because reactants can only produce products, and the products cannot be converted into the reactants. So at the end of the reactions, all of the reactants will be converted into products and none of the reactants will left behind. So that is why these reactions go to completion. They are simply represented by putting a single-headed arrow, as I've shown this, and they can be achieved in an open system. So in examples, I've just written that a reaction between hydrogen and iodine to produce hydrogen iodide and the decomposition reaction of calcium carbonate. So let's just discuss these examples from your book. So let's just discuss the first example, that is of hydrogen and iodine. Hydrogen is colorless gas and iodine is a purple gas. Whenever we combine these two gases in a closed system, as I have shown in this, as you can see from the book, that there is a flask in which this is a closed flask. As you can see, I just have to annotate this one. As you can see that this flask is closed, and in this flask we have filled the hydrogen gas and the iodine gas. The hydrogen gas molecules are colorless, but the iodine gas molecules are purple. So whenever these two molecules, as we know that gas molecules are in random motion, we have studied this, discussed this in class 9. So when these gas molecules collide with each other, they'll form a new substance, that is hydrogen iodide, 2HI, in the form of gas, as it is shown you in this diagram. As you can see that there are hydrogen iodide gas molecules. So how can we be so sure that the hydrogen iodide is being formed in this flask? The purple color of the iodine will disappear. As soon as the hydrogen reacts with the iodine, the purple color of iodine disappears. So we can say that the hydrogen iodide molecules are being prepared. But after some times, when there will be a sufficient amount of products, we can see that the hydrogen iodide in the gas mix in the reaction mixture, the purple color will start to reappear. Why is that so? Because this reaction is a reversible reaction. As you can see, there is a double-headed arrow. So the hydrogen iodide molecule, when there is a sufficient amount or the reaction has attained chemical equilibrium, the hydrogen iodide, this is basically the product, it will recombine to form reactants. It will produce hydrogen and iodine. And whenever the iodine is produced in this reaction mixture, the purple color will reappear. So this is the first example. And I have written in the notes that the reversible reactions can only be attainable in a closed system. So as you can see that this is a conical flask and we have closed this flask. Why it is attainable in the closed system? Because this reaction is in a gas state or in a gas phase. If we have an open conical flask, all the gas molecules will escape out from this flask and we will left with nothing. So that is why a reversible reaction is only attainable in a closed system. But in an open system, we can see that there will be nothing left. So that will be discussed in the irreversible reaction. So let us move on towards the second example, that is calcium carbonate. So this is the second example, calcium carbonate. This is a conical flask again. As you have seen that in the first process, let me just annotate the screen. This is the first process. And this is for the second process. This is for the open system, and this is for the closed system. Whenever we heat the calcium carbonate molecules, they produces calcium oxide and carbon dioxide. Calcium carbonate is solid, so these are the calcium carbonate particles. Whenever we heat this calcium carbonate particles, it produces calcium oxide and CO2. Because this is a decomposition reaction, CO2 being the gas molecule will move upwards. As we know that gases moves upward by gravity, and solids and the liquids move downwards by gravity. So now we can see that in order to reverse this reaction, we need calcium oxide and carbon dioxide. But in an open system, there will be only calcium oxide that will be left behind. No carbon dioxide will be present in this flask. So, as it is written over here, that CO2 forms and goes out. As the system is open, all of the carbon dioxide will escapes out, and only the CaO will be remained in the flask because it is solid and solid moves downwards by gravity. So CaO is left with nothing to react with. So that is why this reaction does not go to completion and it becomes an irreversible reaction. But what if we proceed this reaction in a closed system? So this reaction can be converted into the reversible reaction. As it is the irreversible reaction in an open system, we can convert this irreversible reaction into the reversible reaction simply by just putting a cork, or simply we can say that we can close the system. So now in this case, whenever we are going to heat up calcium carbonate, both of the substances, that are calcium oxide and carbon dioxide, both will be formed. But now there is no path or no passage for the carbon dioxide to escape out. So carbon dioxide molecules will move towards the top, and they will collide with the tap or lid of the conical flask, and after condensing, they'll go down. And whenever they come down, they react with calcium oxide. And when they react with calcium oxide, they again formed calcium carbonate. And so this reaction becomes a reversible reaction. Why? Because we have started from calcium carbonate and have produced calcium oxide and carbon dioxide. But as there is no passage for the carbon dioxide to escape out, so the carbon dioxide again reacts with calcium oxides and forms calcium carbonate. So this is how a irreversible reaction can be converted into the reversible reaction. So now let's move. I hope there will be no issues in reversible and irreversible reactions. So let's move on toward the final two definitions, and let's just close out this lesson, the final two lessons and final two definitions. And inshallah, in the next lesson, we will start from the next topic. So first one is what is a chemical equilibrium state? So chemical equilibrium state is one of the rate of forward and reverse reactions is the same. Forward reaction is the reaction in which the reactants are converted into product. This is the forward reaction. And what is the reverse reaction? In which the product is converted into the reactants. So this is the forward and the reverse reaction. So when the rate of forward and reverse reaction is the same and the composition of the reaction mixture does not change, it remains constant, we can say that the reaction is in the state of chemical equilibrium. Why? Because at the same speed in which the reactants are converted into the products, uh, at the speed at which the reactants are converting into the products is exactly the same as the products are converted into the reactants. So the reaction mixture remains the same or constant. So there are two types of equilibrium. First one is static equilibrium, and the second one is dynamic equilibrium. Static equilibrium is that when the reaction ceases to proceed, it is called static equilibrium. Mostly this is in the physical phenomena, as I've given you the example that a standing building is in static equilibrium because all the forces acting on it balanced are balanced. And what is dynamic equilibrium? A dynamic equilibrium is a process in which the rate of the reaction or the reaction does not stop, but the forward and reverse reaction takes place in the opposite direction. So, and this is the main or the best condition, that the rate means the speed of the forward reaction and the speed of the reverse reaction is the same. So this is all for today's lesson. I hope you have cleared this concept. If you have any questions, you can ask in the comment section and I'll try to answer all of your questions.